I want to welcome you to another segment of linear programming, that is inequalities we are looking at in our mathematics paper 1. And today I'll focus on answering the 2022 paper 1 internal. So this question that you are able to see on the whiteboard there is simply coming from the 2022 paper 1 internal ECZ exams. All right. So now, if you remember some few concepts that we actually talked about when it comes to linear programming, I did tell you a few tricks in order to identify which side is greater than, which side is less than, when you have a solid line or when you have a dotted line. For example, most of the lines, if you look at this one, are actually solid lines. We only have this line there, which is actually a dotted line. So now, according to the question in the 2022 paper 1, which I'll post in the group, you'll be able to see it. The question was saying we write 4 inequalities that define the unshaded region R. So we are talking about this region here. That is the region that we want to write. So we are going to put down 4 inequalities that define the unshaded region R. Now, like I told you, the first thing that you need to do, you can choose which equation you are going to start with based on your preference. But of course, what I can encourage you, those lines that are parallel to either the x or to the y-axis are the simplest that you can start with, and therefore I'm going to number them so that we follow that same sequence when it comes to answering this question. For example, I'll start with this one here. I'll call it as my first equation. Then I'll move on to this equation here. I'll call it the second one. Then I'll move on to this one parallel to the x-axis. That will be my third inequality. Then the last one that we are going to have is this one there. I'll simply call it, in this case, let me label it from this side as my fourth inequality. So we'll proceed answering, finding the 4 inequalities labeled 1, 2, 3, and 4 in that particular order. Now remember what I told you. For example, if you come to the first one, if you look at this line, it is actually parallel to the y-axis. So now you look at where this line is cutting the x-axis. So it is cutting the x-axis at where x is equal to what? Is equal to 4. So I'll start with 1 here. It simply means that the equation for this line, because it is cutting where x is equal to 4, it simply means it is x is equal to 4. Now if you notice, the region that we need is the region, the unshaded region R. So where is it going? It is actually going this side. Now what do you notice about the numbers? If you compare the x-axis, the numbers this side will be decreasing. So meaning that the inequality sign that you use to replace that equal sign is going to be less than. But because this is a solid line, it simply means our inequality is going to be x should actually be less than or equal to 4. So this is our first inequality that we have there. I hope we are together. Let's go to the second one, the second inequality. We are looking at focusing on this line that is there. Again, when you look at this line, it is actually parallel to the y-axis. Where is this line cutting the x-axis? It is cutting the x-axis where x is equal to negative 2. Let me use a different colored piece so that you are able to see that. So it simply means that the equation for that one is x is equal to negative 2. Why? Because this line is cutting the x-axis where x is equal to negative 2. The next thing that we need to do is that we need to supply the inequality sign to replace the equal sign. Now remember again, the region we are talking about, the line is like this and this side is shaded. We are looking for the unshaded region R. So if you notice, going this side, what happens on the number line? The numbers will keep on increasing. No wonder you see from negative 2 it goes to 0, 4, 8, and so on and so forth. So the numbers increase. So what inequality sign are we going to give to this equation? Going this side, the numbers are increasing. It is actually greater than. So you're going to say that x is actually greater than. Now, because this is a solid line, it simply means that you need to add your equal to. So it will be x is greater than or equal to -2. It simply means you have done your second inequality that you have been given. All right, I hope we are together. So you still need to remember, if I can just a quick recap in this case, just to tell you back on that, if you still remember what we discussed, if you have the x or y plane there and have a number there, for example, if that number is actually a 5 and I've got a line that is cutting through 5 there, and they shade in that direction this side, remember going this side is actually less than. Because this is a dotted line, I will not put up the equal to. Going the other side is actually greater than. That's what we did talk about. Suppose I had a line in that direction, maybe here I had a -1 and I had a line passing through here. Then how was it going to be? Well, imagine that we shaded the other side. And remember here where the line is cutting the x-axis is -1. It simply means that going this side is actually still, remember the numbers are increasing, is greater than, but going this side is actually less than. Because this is a dotted line, you are not going to put up the equal to sign. Let me quickly try to erase this one and try to put up some few concepts again there, just to help you remember that again. Suppose you were having now, in this case now, you are having a solid line. Imagine that now you have got a solid line, but this solid line is cutting, in this case, the x-axis at 2. And they have actually shaded in this direction. They want you to identify the region, the unshaded region there. Well, it simply means we'll know that since this line is passing where x is equal to 2 and going this side is actually greater than, then it is going to be x should be greater than. But because this is a solid line, it simply means it will be greater than or equal to 2. That represents your inequality of this unshaded region. Well, you might just say, wow, you are just looking at maybe the x-axis. What about the y-axis? Let's focus now on the y-axis. Let's imagine again you have got a solid line, but this solid line is passing where y is equal to 6, and they may be shade in that direction, and they want you to identify the unshaded region, which is below. Of course, because this line is cutting the y-axis where y is equal to 6, it simply means that for you to, what inequality sign will replace there, numbers going below downward are actually decreasing. So it simply means the inequality sign there you're going to use will be y should actually be less than, but because this is a solid line, remember to include the equal to. So it will be y should be less than or equal to 6. Y, remember, going down here is actually going to be less than or equal to. If you were told to find the region up there, it would have actually been greater than or equal to, because the numbers are actually increasing in that case. All right, so these are concepts I'm just trying to recap, which we did in our previous discussion. Another thing that I want to remind you of is that again, if I've got that direction, x or y plane, remember what I said in this case. Let's now say the line is neither parallel to the x or to the y axis, but it is slanting at an angle. Let's say that it has got a positive gradient in that direction. Remember what we said, going this side of this line will always be, if you still remember, that is always going to be less than. So you are going to use less than. Remember, whether you put the equal to sign would depend. If that is a solid line, then it needs to have less than or equal to. Sorry for that. If you are going up of this line, it simply means it will be greater than. Because that is a solid line, it simply means it will be greater than or equal to. Those are concepts that you need to remember. Okay, some other concept that we talked about. Suppose the line is actually having a negative gradient, a negative slope. Like in what case? Well, imagine that it is now sloping in that direction. Well, if it is having a negative slope, remember what we said, if you are going this side of this line, it simply means that it is actually going to be greater than or equal to. But if you are going below this line in that direction, it simply means it will be less or equal to. I'm including the equal to sign because this is a solid line. If it was a dotted line, it simply means that if you had a dotted line like that, it simply means that those equal to sign will disappear. This side, it will just be greater than, and going this side, it will just be less than. And this is what we are going to apply as we continue with the four inequalities that this question told us. Well, let's get back again, since I've actually given you a few concepts. Let's get back again, to the third, inequality. I'll write it somewhere here. I hope you are able to see. So the third inequality is representing this line. And if you notice, this line is actually parallel to the x-axis, but cutting the y-axis where y is equal to 2. So we are going to say y is equal to 2. Now, if you notice, this line is actually a dotted line. It's a dotted line. Then what region do we want? It is the region represented by the unshaded region represented by arrow going upward there. So what is happening to the numbers as you go up? Of course, they are increasing. Very good. And that's the key concept you need to have. So what inequality sign are we going to use? We are going to use greater than. Now, because this line is a dotted line, you don't put the equal to sign. So it is going to be y should actually be greater than. I'm not going to include the equal to sign because that is a dotted line. So y is greater than 2. This is the third inequality that you have. Of course, I wanted to end with the fourth one because the fourth one is neither parallel to either the x or to the y-axis. So when you are doing, you are finding the inequality of a line that is sloping at an angle, remember there are two things that you need to do. One, you need to find the gradient. That's what we said. So there are two things. Remember, you need to find the gradient of that line. Then two, you need to find what we call as being the equation of the straight line. So find the equation of a straight line. Those are two things that you need. Then you can supply the inequality sign that you're going to have. Now, in order for you to find the gradient, it simply means that you first of all need to identify two coordinates where this line is passing. And of course, in the exam, you always see those to be very visible. For example, if I look at this line, I can see this point here. This is the point. If you look at the point here, this is where x has moved. It is 8, but y has not moved. Remember, coordinates are always given in the form x, y. So you always have to start with the x value, then you go to the y value. So x there is actually 8, but y has not moved because it is along the x-axis. Remember what we said? Along the x-axis, y is always 0. So therefore, this coordinate here will be 8, 0. And again, if you follow this line, it is cutting the y-axis where y is equal to 6. X has not moved anything, but y has moved to 6. So the coordinate of this point is actually 0, 6. So you are going to use these two coordinates to find the gradient, and hence that will help you to find the equation. So let's try to do that. I'm finding the gradient first of all. So using the point 8, 0, and of course 0, 6. Now, of course, remember the gradient says that gradient is equal to y2 minus y1 over x2 minus x1. The change in the y divided by the change in the x step. So remember, you need now to replace, the values in that equation. So we did say that you can label the equations however you want. If these are representing ones and these are representing twos, well and good. Or these can be twos and those can be ones. So for example, let me say this is x2, then this would be y2. then this will be x1 and that will be y1. So these are 2's I've chosen and these are 1's. But another person might have chosen the other way around. The answer will always be the same. So let's try to replace their gradient to be equal to what is my y2? It is actually 0 minus my y1. It is actually, again, a 6 there, over what is my x2? It is actually 8 minus my x1, which is actually a 0. So the gradient there, 0 minus 6 will give us a negative 6 over 8 minus 0 will give us 8. So the gradient, remember what I told you, you can, if you're having an improper, a fraction like that, you can just reduce it to its lowest form. That is what you need to do. So 2 there, I'm going to have a 3, then 2 there into 8 is actually a 4. So therefore, our gradient is negative 3 over 4. Now, like I mentioned, the next step after finding the gradient, you need to find the equation. So from here, we'll now go and find the equation. If you still remember the equation of a straight line, we did say it is y is equal to mx plus c. Remember, what does the m there represent? It represents your gradient. Then what does the c there represent? It represents the y-intercept. So y-intercept means where is this line that you are finding the gradient, the equation for, where at what value is it cutting the y-axis. So if you notice and you come back again, this line is cutting the y-axis where y is equal to what? To 6. So our y-intercept is 6, so you don't need to waste time. Remember, I talked about this in our previous discussion many times. So I can now write the equation. It will be, I replace the gradient, which I found here, the y-intercept, which I know is a 6, because that is where this line is cutting the y-axis. It is on the value where y is equal to 6, and that is your y-intercept. So it will be y is equal to my gradient. It will be negative 3 over 4x plus my y-intercept, where it is cutting the y-axis, the equation is cutting the y-axis, it is a 6. So here it will be 6. So once you find the equation now, you need to supply the inequality sign. So if you notice, the line is actually here, and the region that we want is the region going there. So with those concepts I gave you, going this side, we said it is actually less than. But of course, if you notice, this is a solid line. So what inequality sign are we going to use there? It is going to be y should actually be less than or equal to negative 3 over 4x plus c. This is your fourth inequality. So if you notice again, that is the way we supply these inequalities. And remember, in the exam, these questions will always carry 5 marks. And mostly question number 21 in your paper 1 will always have linear programming. And hence, get down to your toolbox and actually try to go through this discussion. So remember, this is one of the inequalities that we had. So we started there. These are the inequalities that they wanted you to write. So you can actually, in your paper 1, there's always space indicated where you can now rewrite these, but your working has to be shown. Well, thank you so much. This is the end of this segment of the video. I will try to create another video so that you are able to see how we can further demonstrate this concept. Otherwise, see you in my next video. Bye-bye.